Yes folks, we're back with the video. Now we are with the problem number 3. This is our application on maxima and minima. We are doing the problem number 3 now. Let's take this problem number 3 and see what it says. It says that f of x is minus x minus 1 the whole squared plus 10. As before, now we'll just try to understand how the graph could look so that it gives us an idea of what could be the maximum, what could be the minimum, and then we would work algebraically and get the answer. That's how it is. As I told you, linears, they will behave like x itself. So you can look at this function. No, it's like as though it's y equal to minus x squared plus 10. Now to avoid the complexity, let y be minus x squared. Now we know this. We know the parabola x squared equal to minus y. Generally, how does that parabola looks? It looks like this. This is your parabola x squared equal to minus y. So because it is plus 10 here, it means that this will shift. The origin will shift. The graph will be no longer passing through the origin, but rather it will pass through 10. If 10 is there here, it will pass through 10. That's the meaning of this plus 10. So basically this is our graph. Now because there is this because there is this x minus 1, it will not be symmetric about the y-axis. It will be a little here or there. So probably this graph would be looking like this. The graph would be probably something like this. If 10 was here, then with the proper plotting, probably it would be something like this. Now from this itself, it's very clear to us, when we look at the graph, what could be the maximum, what could be the minimum. It's very clear to us that there is a maximum point and the maximum is happening at 10. But there's no minimum point because as we change the values of x, the minimum keeps on changing. So that's that idea we get from the graph itself. Now we go for the algebraic part. In the algebraic part, we'll see, because there's already a square, let's take care of that square. We know that x minus 1 the whole square is always positive. Squares are always positive. Obviously, when you attach a negative with it, it is going to be always negative. That's it. Because the one that is given to us is minus x minus 1 the whole square. So this is going to be always negative. In order to reach the function, we require a plus 10. So let's add a 10 to both sides. X minus 1 the whole square plus 10, 0 plus 10. So that's 10. So this is also f of x. So you get to know that f of x is always less than or equal to 10. That means that your function has got a maximum value, and that maximum value is 10. And that's how it is. Minimum value we cannot determine, right? And that comes through this. So we'll write, therefore, the maximum value is 10 and the minimum value does not exist, as we did before. Why? Because as we change the value of x, it keeps on changing. So that is why there is minimum value means least. There's no value below it. So we will not be able to find that. So that is why this is how it is. Quite easy. Once you understand the graphical part, then it's very easy for us to anticipate and do the problem. On the same lines, we can move to the fourth subpart where they give us a question, g of x as x cube plus 1. X cube is a known function to us. X cube, we have done it, as a standard function even last year and even this year. So x cube is a known function. X cube plus 1 means it's like x cube, but instead of passing through the origin, it will pass through 1, just that way. So if we know the graph well, we know that x cube is a graph which looks like this. It's a graph which looks like this because it passes through the origin. Now because it is plus 1, it will not pass through the origin. In fact, it will pass through 1. So let's see how it is. So it's like there is a 1 here, and the same behavior will be through 1. That's it. So this is the graph. Now when we look at the graph, are we able to find out the maximum or the minimum value? As you keep on changing the value of x, the value of g of x keeps on changing, it keeps on increasing. So also as you keep changing the values of x from the negative side, the value of gx keeps on reducing. That means you are not able to get a proper maximum or a proper minimum value. So in this case, there is actually no proper maxima, no proper minima. Now there are different ways of doing this. We'll find that the reference books, each book, they do it differently. Basically here what we'll do is we'll try to plot some points, and then it's like kind of by induction, no? Because of these points, as we plot the points, the values are keeping on changing, so we will generalize it like that. So let's generalize it like this. Here for x equal to 1, what is our g of x value? It is 1 cube plus 1, which is 2. Take x equal to 5, so g of 5, it is 5 cube plus 1, which is 126. Take x equal to 15. What is your g of 15? Let's find out. It is 15 cube plus 1. Now this we need to find. 15 cube, 15 square is 225 into 50. Let's find out. 15 5s are 75, 7 carry. And 15 to the 30, 37, 3 carry. 15 to the 33 get 33, 3375 plus 1, 3376. So what do we see? That with the increase in the value of x, the g of x value is also increasing. So you can write as x is tending to infinity, g of x is also tending to infinity. No, that's it. That's the meaning of telling that as you keep on increasing the values of x, g of x value is also increasing. So this is one thing. Also, you look at values of x now for negatives. Take x as minus 1. When you take x as minus 1, g of x is minus 1 cube plus 1, which is minus 1 plus 1, 0. Let's take x as, say, same like this, 5. Maybe we'll take 7 or something. So let's take what is g of, not 7, minus 7. G of minus 7. Minus 7 cube plus 1. Minus 7 cube means 7 into 7 into 7, 49 into 7. So that is, we know it, but let's check 49 into 7, 63, 28 and 6, it's 34, 343. So negative 343 minus 343 plus 1 minus 342. Then x going to, so x equal to something like minus 20 or something, easier calculation. So g at minus 20, let's calculate. Minus 20 whole cube plus 1 is minus 8000, we know it. Minus 8000 plus 1, that is minus 7999. Right, so what we observe here, as x tends to minus infinity, it's going on that side. How is the g of x value? That is also going to minus infinity, isn't it? So therefore, there is no maximum and minimum value. Okay, so that's about it. About the maximum and minimum values, how it happens. So that's all for this part. Then in the question number 2, we have different nature. There also we are deciding maximum and minimum. These are mostly parabola kind of curves, except for the last one. There it's slightly different. So with more problems, we'll come in the next video. It goes without saying that we all have a mixed responsibility of popularizing the channel and making it known to everybody. Thank you.